Welcome to part 3 of this series. In this video, we continue to practice cross-product method by solving more challenging examples. Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything. Hello, this is the third session of factorization. In this session, we still focus on using factorizing formulas and the cross-product method through a few examples. Question 1. Factorize x plus 7 all in parentheses squared plus 9 times open parentheses x plus 7 close parentheses plus 20. After seeing this kind of question, some of you may immediately expand the two parentheses and combine the likely terms and then proceed with factorization. However, x plus 7 itself can be treated as a single variable. We can name it y or other variable, or just keep current form as it is. We may apply the cross-product method to factorize it. As we've seen, the quadratic factor is just x plus 7 all in parentheses squared, while the constant term 20 can be factorized as 1 times 20 or 2 times 10 or 4 times 5. We choose to factorize the term 4 times 5 because we need to match the linear factor 9 times open parentheses x plus 7 close parentheses. In this way, it matches the linear term 9 times x plus 7 all in parentheses. As it can be seen, the factorization can be done by applying the cross-product method. Question 2. Factorize 6 times open parentheses x minus 3 close parentheses the squared plus 13 times open parentheses x minus 3 open parentheses plus 5. This question is a similar type of the previous one. As explained just now, we do not need to expand the parentheses and then combine the likely terms. Instead, the whole of x minus 3 can be regarded as a variable, and we may apply the cross-product method to factorize it straight away. Technically, we need to try and combine various factors of quadratic and constant terms to make them match the linear term in the middle. Here is what we have done for this question. Question 3. Factorize x squared minus 6x plus 9 minus 16 times y squared. This is a quadratic expression with two variables, and there's no common factor found among all the terms. After carefully observing the question, we find the first three terms can be formed a competing squared, as shown here. X squared minus 6x plus 9 can be expressed as x squared minus 2 times x times 3 plus 3 squared, and it becomes x minus 3 all in parentheses squared, while 16 times y squared actually is 4y all in parentheses squared. So the expression turns to be the form of the difference of two squares, and we can further factorize it as it displayed here. Question 4 is asking to factorize x squared plus y squared minus 25 and minus 2xy. Following the last example, this is a similar type of question. You may try it out yourself and see if you can do it comfortably. However, we go ahead and explain this question straight away here. Based on the observation, three terms x squared, y squared, and negative 2xy can be factorized as a competing square. It is x minus y all in parentheses squared, while 25 is just 5 squared. So we rearrange this expression and then proceed with factorization as displayed here. Question 5 is asking to factorize a squared times open parenthesis b minus c close parenthesis plus b squared times open parenthesis c minus a close parenthesis plus c squared times open parenthesis a minus b close parenthesis. First, there's no any common factor can be found among all the terms, and we can't apply any existing formulas directly. However, we can try to expand these terms and then find the terms with the same color can be grouped together, and in this way there is a common factor in each group, which is a minus c. After taking out this a minus c common factor, the remaining terms can be further regrouped, and b minus c is a common factor between them. Finally, we complete our factorization task, and the result is displayed here. Question 6. Factorize ax plus by all in parentheses squared plus ay minus bx all in parentheses squared plus c squared y squared plus c squared x squared. First, there is no common factor among all the terms, and there's no way to directly apply any formula to factorize this expression. However, after careful observation, we find the middle terms of the two competing squares can be cancelled out each other after being expanded. They are showing in red color here. So we expand these two competing squares and proceed to regroup them to find out there is a common factor, which is x squared plus y squared. They are showing red color here. After taking out this common factor, the factorization is completed. Question 7. Factorize the expression x squared plus ab minus ac plus ab plus b squared minus bc plus c squared minus ca minus cb. Careful observation leads us to recall the three variables quadratic formula, as shown here in red here. The next step is to link the expression to be factorized to the formula displayed in red. Here we use negative c to match the capital C in the formula, and they just perfectly match. So we use the formula to complete our factorization. If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.